Europa should not look alive. From far away, it looks almost too clean. A pale white moon moving through the darkness beside Jupiter, with no clouds, no blue oceans, no forests, no weather that a human eye would recognize. It does not glow with warmth. It does not wear the colors of a living world. It is ice, shadow, and scars, wrapped around a body smaller than our moon, yet pulled so deeply into Jupiter's gravity that even its silence feels forced. And that is the first deception, because Europa's stillness is not peace. It is pressure held in place. Every few days, this moon loops around Jupiter, and every time it does, the giant planet grips it with gravity, stretching and flexing it from the inside. The surface remains frozen, but the world underneath is not allowed to rest. Rock, ice, and ocean are caught in a slow, mechanical struggle. Europa is squeezed the way a hand might squeeze a sealed vessel, again and again, until the question is no longer whether the surface is cracked, but what those cracks are hiding. For decades, Europa has been one of the most tempting worlds in the solar system because beneath that ice there is strong evidence for a global ocean. Not a small pocket of meltwater, not a temporary lake, a vast, dark ocean sealed away from sunlight. It is one of the few places beyond Earth where the word habitable can be spoken without sounding like fantasy. But habitability is not the same as comfort. Europa does not orbit gently in a quiet corner of space. It lives inside Jupiter's enormous magnetic field, a place where charged particles are trapped and accelerated until the surface of the moon is constantly bombarded by radiation. Any chemistry exposed on the ice is not simply preserved, it is attacked, broken, rearranged and rewritten. The surface is not a museum, it is a battlefield. That is what makes the James Webb Space Telescope's look at Europa so unsettling. Webb was not searching for monsters under the ice. It was not listening for a signal. It did not find a city, a creature, or proof of life. What it did was quieter, colder, and in some ways more disturbing. It took the light reflected from Europa and split it into a spectrum, turning a faint moon into a chemical document. In that document, Webb found carbon dioxide concentrated in one of the most damaged-looking regions on the moon. The place is called Terra Regio. To an ordinary viewer, it might look like another pale patch on an already scarred world. But to planetary scientists, chaotic terrains like Terra Regio are not ordinary. They are places where the surface seems to have been disrupted, broken apart, and rearranged, as if the crust once lost its ability to behave like a single solid shell. Blocks of ice appear displaced, patterns become confused, smoothness gives way to disorder. Something happened there, and the surface still carries the memory of it. So when Webb found carbon dioxide especially concentrated in Terra Regio, the meaning was not simply that Europa has carbon on its surface. Carbon dioxide had been seen on Europa before. The disturbing part was the location. It appeared most strongly in a region already suspected of being geologically young, altered, and possibly connected to material from below. That turns a chemical detection into a question with weight. Did this carbon come from outside, delivered by impacts or dust? Was it created on the surface by radiation smashing and transforming other compounds? Or did some of it begin deeper inside Europa, perhaps in material linked to the hidden ocean, before being carried upward and exposed on the ice? Webb cannot answer that final question alone, but its data made one possibility harder to ignore. Europa's surface chemistry may not be sealed off from the interior. The ice may not be a perfect lid. The frozen crust may be more like a damaged wall, and in certain places, traces from the hidden world beneath may be reaching the outside. That is the real horror of Europa. Not a monster, not a scream, not a dramatic image of something moving under the ice. The horror is that this moon, which looks dead from a distance, may be quietly leaking clues from an ocean no human has ever seen. Imagine standing above that ocean, if standing were possible. Above you would be miles of ice. Below you, black water. No sunrise, no moonlight, no sky. The only energy would come from the slow violence of gravity and chemistry. Rock meeting water, ice flexing overhead, salts and carbon compounds moving through a world locked away from the sun. If anything there is changing, reacting, or surviving, it is doing so in a darkness so complete that earthly ideas of life begin to feel provincial. And yet the only clues we can reach are not in the ocean itself. They are on the surface, where Jupiter's radiation is constantly damaging the evidence. That is why Webb matters. It does not need to drill through the ice to change the story. It can read the surface with enough precision to ask whether certain materials are randomly scattered, externally delivered, or concentrated in places that look geologically meaningful. It can look at a moon from across the solar system and tell us that one broken region is chemically different from another. In human terms, it is like examining a locked door and noticing that the dust around the frame does not match the dust in the room. The door has not opened in front of you, but something has passed through. Europa's ice has always been the centre of the mystery, but Webb made the ice feel less like a blank shell and more like a witness. It is not just covering the ocean, it may be recording the ocean. It may be destroying that record in some places, refreshing it in others, and preserving just enough for a telescope near Earth to catch the outline of a story. The mistake is to imagine that ice means death. On Earth, ice often preserves, it stops motion, it locks things in place. But Europa's ice is not just a freezer. It is a mechanical shell around a restless interior, exposed to radiation from above and possibly altered by ocean chemistry from below. It is squeezed, cracked, resurfaced, irradiated, and chemically transformed. It is not the opposite of activity. It may be the evidence of activity. And that changes the way Webb's discovery feels. A small amount of carbon dioxide on an icy moon might sound like a detail, but in the search for habitability, details are everything. Carbon is one of the elements that life as we know it uses to build complexity. That does not mean life is there. It does not even mean Europa's ocean is friendly, but it means the chemistry of the ocean matters. And if carbon-bearing material can reach the surface, then the ocean may not be forever beyond investigation. The question is no longer simply whether Europa has water. The deeper question is whether Europa has a pathway from ocean to ice, from darkness to surface, from hidden chemistry to detectable fingerprints, from a world sealed beneath kilometers of frozen crust to a faint spectral signal caught by a telescope more than 1 million kilometers from Earth. And Webb has not opened that door. It has shown us that the door may have marks around the edges. The first instinct is to imagine Europa's ocean as something waiting patiently under the ice, untouched, preserved, almost pure, a hidden sea, protected from space by a frozen ceiling. But that picture is too gentle. Europa is not a snow globe. It is a pressure system. The ice above the ocean is not just sitting there. It is being pulled, stressed, cracked, warmed from below, frozen from above, and punished from outside by Jupiter's radiation. Every layer of Europa is caught between forces that do not agree with each other. The surface wants to become a dead, irradiated crust. The interior wants to move. Jupiter will not stop flexing the moon, and somewhere between those forces, chemistry may be dragged from darkness into light. That is why Terra Regio matters so much. A smooth field of old ice would be interesting. A random dusting of carbon dioxide would be interesting. But carbon dioxide concentrated in a chaotic terrain changes the emotional shape of the evidence. It points our attention to a place where Europa's crust may have been disturbed, where blocks of ice may have shifted, where warmer or chemically different material may have once reached closer to the surface. No single observation can turn that into certainty. Science does not work by turning one bright clue into a complete story. but it can tell us where the story becomes worth following. Webb did not reveal an ocean directly. It revealed a place on the surface that behaves as though the surface is not isolated from what lies beneath it. The more you think about that, the stranger Europa becomes. On Earth, we are used to oceans being open. They breathe into the sky. They exchange heat with the atmosphere. They absorb sunlight. They carry waves, foam, storms, and life at the surface. We can stand beside them and see that they are alive with motion. Europa's ocean, if it is there, as the evidence suggests, is the opposite. It has no open horizon. It does not glitter under a sunrise. It has no shore where a wave can break into air. It is a buried ocean, wrapped in ice, circling a planet so huge that Jupiter would dominate the sky from the surface, like a permanent god of gravity. But buried does not mean disconnected. That is the dangerous idea. If Europa's ice shell is completely sealed, then the ocean becomes almost unreachable. It may still be fascinating, but its secrets stay deep. A spacecraft flying overhead can map the surface, measure magnetic effects, study gravity, and search for hints, but the ocean itself remains locked away. To truly sample it, you would need to land, survive radiation, drill through unknown kilometers of ice, avoid contamination, and reach a dark sea no machine has ever touched. But if material can move upward, even occasionally, then Europa changes from a locked vault into something more complex. The ocean might be writing faint messages onto the ice. Not messages with intention, not signs made for us, but chemical traces left behind by geological processes. Salts, carbon compounds, altered ice, radiation products, fragments of an interior environment scattered across a surface that keeps trying to erase them. That is what makes the surface both precious and cruel. It may contain the best accessible clues to Europa's ocean, and it may also be the place where those clues are most violently damaged. Jupiter's magnetic field turns Europa's surface into a laboratory that never closes. Charged particles slam into the ice. Molecules are split apart. New compounds form. Old compounds are destroyed. A molecule that began in the ocean could arrive at the surface and immediately enter a storm of radiation chemistry. By the time Webb sees it, the original story may already be partly rewritten. So when scientists look at Europa, they are not simply asking, what is present? They are asking, what survived? What was transformed? What was delivered from outside? What was made in place? What came from below? What has been buried, exposed, destroyed, and remade? Europa forces every clue to pass through suspicion. That is why a detection like carbon dioxide is not small. It sits inside a chain of questions. Carbon matters because it is one of the basic elements of organic chemistry. Carbon dioxide is not life, but it is part of the chemical vocabulary of habitable environments. Its location matters because a random global coating would suggest one story, while a concentration in disrupted terrain suggests another. And the terrain matters because chaotic regions may be some of Europa's most important windows into the interaction between surface and interior. The horror, if that word belongs here at all, is not that Europa is hostile. Many worlds are hostile. The horror is that Europa may be both hostile and promising at the same time. It may have water, energy, and useful chemistry, the three ideas that keep pulling astrobiology back to this moon. Yet all of that possibility is buried under an ice shell and exposed at the surface only in damaged hints. The same world that may preserve an ocean also hides it. The same ice that protects the interior also blocks us from reaching it. The same radiation that creates interesting chemistry also destroys evidence we want to understand. Europa is not a simple hope. It is a contradiction. And Webb's contribution was to sharpen that contradiction. A telescope built to study the early universe, distant galaxies, exoplanet atmospheres, and cold cosmic dust, also turned its instruments toward a moon in our own solar system, and found that one of the most important questions in planetary science may be written in patches of altered ice. That is easy to miss because the data does not look dramatic to the public. It is not a cinematic photograph of an alien sea. It is not a plume erupting in front of the camera. It is a spectrum, a pattern of absorbed and reflected light, a quiet mathematical fingerprint. But some of the most important discoveries in space do not arrive as images. They arrive as missing light. A molecule absorbs certain wavelengths, a surface reflects others, an instrument records the pattern, then scientists compare that pattern to what different materials should do. Out of that process comes a map, not of mountains or craters, but of chemistry. Webb can look at a moon and ask what its surface is made of, region by region, with enough sensitivity to make certain places stand out from the rest. And Tara Reggio stood out. That is where the story tightens. Because if the carbon dioxide there is linked to Europa's interior, then the surface is not just a radiation-burned mask. It is a damaged messenger. It may be carrying altered material from a deeper environment into a place where our instruments can reach it. But the messenger is wounded. By the time a molecule reaches the surface, if it reaches the surface, it has crossed a world of ice. It may have been trapped, mixed, frozen, broken, buried, exposed, and irradiated. The clean ocean signal we want may never arrive clean. Europa does not hand over answers, it hands over fragments. And that may be why this moon feels so unsettling. It is not silent because nothing is happening. It is silent because the evidence has to fight its way out. A photograph can make Europa look simple. A bright disk, a few reddish fractures, a moon small enough to fit neatly beside Jupiter in a diagram, as if it were only a decorative companion to the giant planet. Images have a way of making distant worlds feel finished. They give the eye a surface and let the mind believe it has understood the object. But Webb was not built merely to admire surfaces. Its real power is that it can turn light into evidence. When sunlight touches Europa, some wavelengths are reflected back, and some are absorbed by the materials in the ice. Different molecules leave different absences in that light. A clean patch of water ice does not reflect the same way as ice mixed with carbon dioxide, salts, sulfur compounds, or radiation-altered material. To a human eye, those differences may vanish into whiteness. To an infrared instrument, the surface becomes a page covered in faint chemical handwriting. That is why Webb's discovery does not need to look dramatic to be dramatic. The telescope did not have to watch the ice split open. It did not have to see a plume erupt into space. It did not have to catch something moving under the crust. It only had to notice that certain wavelengths were missing from Europa's reflected light, and that those missing wavelengths formed a pattern consistent with carbon dioxide in a particular region. That may sound clinical. It is anything but. Because every molecule on Europa's surface has a history. It either arrived from outside, formed on the surface, or came from somewhere within the moon. Each possibility tells a different story about the world. Material delivered by impacts would make Europa part of the wider dust and debris environment of the Jovian system. Material formed by radiation would make the surface a chemical reactor. Material from the interior would mean something far more provocative. That the sealed world below may be communicating with the frozen world above. The difficulty is that Europa allows all three stories to overlap. Space does not keep evidence tidy. Micrometeorites strike the surface, charged particles from Jupiter bombard it. Ice grains migrate. Terrain is broken and rearranged. The same compound can be created, destroyed, transported, buried, and exposed again. By the time Webb sees a chemical signal, it is not seeing a simple label. It is seeing the final visible state of a process that may have passed through many stages. That is what makes Tara Reggio so important. It is not only a location, it is context. If the carbon dioxide had appeared evenly across Europa, The simplest explanation might have been a global surface process. If it had appeared only in a pattern easily explained by incoming particles, that would point in another direction. But the concentration in a disrupted, chaotic region pushes the question toward geology. It asks whether the terrain itself helped expose, preserve, or produce the material Webb detected. And chaotic terrain is one of Europa's most haunting surface features. It looks as if the ice shell briefly forgot how to be solid. Plates appear to have shifted. Blocks seem embedded in smoother material. Lines break, rotate, and reconnect in ways that suggest deformation on a scale difficult to make sense of at first glance. Some scientists have compared these regions to places where the crust may have interacted with warmer ice, brines, or pockets of melt. The exact mechanisms remain debated, but the emotional meaning is clear. These are places where Europa does not look frozen in the ordinary sense. It looks disturbed. So Webb's carbon dioxide signal lands in a landscape that already feels like a wound. A wound does not prove what caused it, but it tells you where the body was stressed. That is the shift the viewer has to feel. Europa is not interesting because it is pretty. It is interesting because its beauty is a disguise for strain. Those long reddish lines are not decoration. The bright plains are not calm. The chaotic regions are not random blemishes. They are the visible consequences of a moon being pulled, flexed, irradiated, and possibly refreshed from within. The surface is the place where all of Europa's contradictions meet. From above comes radiation, harsh enough to alter chemistry and make the surface dangerous to anything fragile. From below may come ocean-linked material, carrying carbon and salts upward through fractures, disrupted terrain, or slow movement inside the ice shell. Between them is the crust itself, thick enough to hide an ocean, but perhaps not thick enough to silence it completely. That is why Europa is so different from Mars in the imagination of exploration. Mars invites us to search through ancient ruins of habitability, dried rivers, lake beds, minerals left behind by water that vanished or retreated. Europa is not a fossil of a habitable world. It may be a habitable world hidden behind a barrier. Mars asks what happened. Europa asks what is happening now, where we cannot see. And Webb's observation makes that question harder to dismiss. A telescope cannot drill, it cannot swim, it cannot taste the ocean or measure its currents, but it can tell us that the surface is not chemically uniform. It can show that a specific compound is concentrated in a specific kind of terrain. It can help choose where future missions should look more closely, where an orbiter should map in greater detail, where a lander might one day need to go if humanity ever attempts the most difficult kind of sampling in planetary science. Collecting evidence from an ocean without touching the ocean directly. That future is not abstract anymore. Europa has become a target not because it is easy, but because it is one of the rare places where the question of life beyond Earth can be reduced to physical investigation. Not belief, not imagination, not mythology. Chemistry. Ice thickness, surface composition, ocean salinity, energy sources, exchange between rock, water, and ice. If the right materials are there, and if they can move, and if energy is available, then Europa becomes more than a beautiful possibility. It becomes a test. But tests can be cruel. They can tell us that the ingredients are present, but the pathway is blocked. They can reveal chemistry without biology. They can show us an ocean that is real but unreachable, active but uninhabited, rich in clues but too altered at the surface to interpret cleanly. Europa may become the place where hope becomes more precise and more painful at the same time. That is what Webb has done to the story. It has not solved Europa. It has sharpened Europa. It has taken a moon that already haunted scientists and made one region of its ice feel like a message pressed through a frozen wall. The message is not clear yet, but it is no longer blank. To understand why a thin chemical signature on Europa matters, you have to shrink the whole moon down to a problem of contact. A world can have water and still be dead to us if that water never touches anything useful. It can have rock and still fail if the rock never interacts with the ocean. It can have carbon and salts and energy, but if those ingredients remain trapped in separate layers, the moon becomes a locked cabinet full of parts that never meet. Habitability is not just about having the right ingredients. It is about whether the ingredients can find each other. That is where Europa becomes both promising and frightening. Its ocean may sit directly above a rocky seafloor. If that is true, then the deepest part of Europa could be the most important part of the whole moon. On Earth, the meeting place between ocean and rock can create chemical energy. Hydrothermal systems on our own seafloor show that life does not always need sunlight as its first source of power. It can survive in darkness if chemistry provides a way to move energy through the system. Europa may have that possibility, but possibility is not proof. And this is where the story has to stay honest. We do not know whether Europa's seafloor has the right kind of chemical activity. We do not know how much exchange happens between rock and ocean. We do not know whether the ocean is chemically friendly, too salty, too oxidized, too starved, or too isolated. We do not even know how easily material from the ocean can move upward through the ice shell. Every hopeful sentence about Europa has to pass through a wall of unknowns. And yet, Webb's observation makes one of those unknowns feel less abstract. The question of Europa is not only what lies below, it is whether below can leave fingerprints above. That is why a concentration of carbon dioxide in Tara Regio feels like a clue placed in the most provocative possible setting. Tara Regio is not just a dot on a map. It is a region where Europa's surface looks physically unsettled, as though the ice has been disrupted and reworked. If carbon-bearing material is concentrated there, then scientists have to ask whether the chemistry and the geology are connected. Maybe the material came from the interior, maybe it was exposed by resurfacing, maybe it formed from compounds that were already there, altered by radiation after the terrain changed. Maybe the truth is not one clean pathway, but a sequence of processes: interior material rising, ice deforming, surface exposure, radiation damage, chemical transformation, then infrared detection by Webb long after the original event. That sequence is exactly why Europa is so hard to interpret. The moon does not preserve evidence like a sealed envelope, it edits it. The surface is a draft written by geology and then overwritten by radiation. One region may be young enough to remember the interior, another may be old enough to have forgotten everything except the damage of space. The same kind of molecule can mean different things depending on where it is found, how concentrated it is, and what other materials sit around it. So the carbon dioxide is not the answer, it is a thread. Pulling on that thread leads into Europa's entire system. The ocean below, the ice shell above, Jupiter's magnetic assault from space, and the possibility that material is exchanged between layers. If the thread holds, Europa becomes a world where the hidden ocean is not completely hidden. If it breaks, the moon is still fascinating, but the path from surface evidence to ocean chemistry becomes much more uncertain. That uncertainty is not a weakness in the story, it is the story. Because Europa sits right on the boundary between what we can measure and what we desperately want to know. We can measure the surface, we can infer the ocean, we can model the interior, we can compare spectral signatures, we can use physics to estimate how ice deforms and how radiation changes molecules. But the thing that would change everything, the direct chemistry of the ocean itself, remains out of reach. This is why Europa feels different from an ordinary distant object. A galaxy billions of light years away is unreachable in a clean, obvious way. We understand the distance as absolute. Europa is close enough to tempt us. It is in our solar system. Machines can go there. Missions can fly past it. Instruments can map it. One day, perhaps, a lander could touch it. And yet, the most important place on the moon may still be sealed under ice thick enough to turn exploration into an act of engineering audacity. The closeness makes the barrier crueler. Webb adds another layer to that cruelty because it gives us something real but incomplete. A signal, a region, a chemical clue. Enough to make the ocean feel present, not enough to tell us what the ocean is. Enough to suggest connection, not enough to prove the full pathway. It is like hearing one note through a wall and realizing there may be an entire room on the other side. But the room may be nothing like we imagine. When people hear ocean, they bring Earth with them. They imagine blue depth, soft motion, maybe life drifting in dark water. But Europa's ocean, if we could enter it, might feel utterly alien. The water could be loaded with salts and chemical gradients unfamiliar in their balance. The ceiling would be ice, not sky. The pressure would be immense. The only light would come from whatever machine brought us there. If life existed, it would not have evolved under a sunlit atmosphere. It would belong to a world where darkness is normal and the surface is lethal. And if no life exists, Europa may be even more scientifically revealing. A sterile ocean with complex chemistry would still matter because it would show how close a world can come to habitability without crossing the threshold. It would teach us that the ingredients of life are not the same as life. It would force us to ask what hidden condition was missing. The failure would not be empty. It would be diagnostic. That is the deeper reason Webb's result is important. It does not give Europa a simple answer. It gives the Moon a sharper question. What kind of world produces carbon dioxide in a broken region of ice? A dead moon with surface chemistry alone? An ocean world leaking altered material through a damaged shell? A chemically active system where radiation and interior exchange combine into something our categories are still too simple to hold? Europa does not let us choose easily. It sits there under Jupiter's glare, bright enough to see, too sealed to understand, offering hints that become more unsettling precisely because they are not enough. The more Webb sees, the less Europa feels like a frozen object, and the more it feels like a process still happening behind a locked door. And the door is made of ice. The ice is the part of Europa we can see, but it may also be the part that lies most convincingly. From a distance, ice feels like an ending. It suggests stillness, preservation, a world whose story has been paused. On Earth, ice can trap ancient air, hold old footprints, and bury memories for thousands of years. It can make time feel slow. But Europa's ice is not that kind of ice. It is not simply a frozen lid sitting quietly over a dark ocean. It is a moving, stressed, irradiated, chemically altered shell around a moon that Jupiter keeps bending. That one difference changes everything. If Europa were orbiting alone, far from the violence of a giant planet, its interior might have cooled into deep stillness long ago. But Europa is not alone. It is part of a gravitational machine. Jupiter pulls on it. The other large moons help disturb its orbit. That disturbance prevents Europa from settling into a perfect circle. And because the moon's distance from Jupiter changes slightly as it travels, the strength of Jupiter's pull changes too. The result is tidal flexing, a slow kneading of the moon's interior. It is not dramatic in the human sense. Europa does not visibly pulse like a heart. The ice does not rise and fall in waves that a person could watch from orbit. But across geological time, that flexing can become heat. It can keep the interior from freezing completely. It can help maintain an ocean where ordinary distance from the sun should have made one impossible. This is one of the strangest truths about the outer solar system. Sunlight fades with distance, but habitability does not depend only on sunlight. A moon can be warmed by gravity, a world can be kept alive, or at least chemically interesting, by being trapped in the pull of something larger than itself. Europa may exist in that narrow, unsettling category. Too far from the sun for surface warmth, but not free enough from Jupiter to become completely frozen inside. The surface records the punishment. Europa's long fractures stretch across the moon like lines drawn by stressed summer reddish, stained by non-ice materials whose exact mixtures are still debated. Some regions are smooth and bright, others are chaotic, broken into blocks and disrupted patterns. The moon looks less like a simple ice ball and more like a shell that has been forced to adjust again and again to motion underneath. But the most important motion may not be visible as motion at all. It may be exchange. If ocean material can enter the ice shell, even through slow, complicated pathways, then Europa's surface becomes a place where the deep interior leaves altered traces. Those traces may not be pure. They may not rise as clean ocean water and freeze neatly in place. They may pass through brines, pockets of warmer ice, fractures, impurities, and radiation chemistry before they ever become visible. But even altered traces matter because they are closer than the ocean itself. Webb's detection sits inside that possibility. Carbon dioxide concentrated in Tara Regio does not prove that ocean water erupted there. It does not prove that the carbon came directly from the ocean. The responsible interpretation is more careful. The carbon is likely derived from an internal source or from ocean-linked material processed at the surface. And the location makes that possibility especially interesting. Tara Regio is a place where the ice appears disrupted, and that disruption gives the chemistry context. This is where science becomes almost forensic. A detective does not only ask what was found, they ask where it was found, what surrounded it, what could have moved it, what could have altered it, and what alternative explanations still survive. Europa demands the same discipline. Carbon dioxide by itself is not enough. Carbon dioxide in chaotic terrain is more important. Carbon dioxide on a radiation-battered surface is more complicated. Carbon dioxide on an ocean world becomes a clue that points in several directions at once. The honest version of the story is more powerful than the exaggerated one. If someone says Webb found life on Europa, the mystery collapses into false certainty. It becomes cheap. It becomes a headline with no foundation. But if Webb found chemistry that may be connected to the interior of a frozen ocean moon, then the mystery becomes larger, not smaller. It forces the viewer to sit with the most difficult kind of suspense, the kind where the evidence is real, but the meaning is not yet fully unlocked. That is why Europa is so hard to let go of. It keeps offering almost answers. A global ocean, probably there. A rocky seafloor, possibly interacting with that ocean. An ice shell, thick but not necessarily sealed. Surface chaos, suggesting disruption. Radiation chemistry, altering everything exposed. Carbon dioxide, concentrated in a region that may matter. Newer spectral evidence pointing to ice that may be modified, crystalline in places, and stratified in ways that suggest the surface is not a single simple layer. Each clue is incomplete. Together, they begin to form a world that feels active in every direction, except the one we most want to see. We cannot watch Europa's ocean circulate. We cannot see its seafloor. We cannot measure its chemistry directly. We cannot say whether it is friendly to life or hostile to it. But we can see that the surface is not meaningless. It has patterns. It has chemistry. It has terrain that seems to remember stress. It has regions where the boundary between inside and outside may be more complicated than a simple wall. And that is the real shift. Europa used to be imagined mostly as a hidden ocean under ice. Webb helps push the story toward a more unsettling possibility. Europa may be a whole connected system, where ocean, ice, radiation, and geology are all interacting. Not cleanly, not obviously, not in a way that gives us a single answer, but enough to make the surface feel like the damaged edge of something deeper. The more connected Europa is, the more important it becomes. A sealed ocean is fascinating but remote. A connected ocean is testable. If interior material reaches the surface, then future missions may not need to reach the ocean directly to learn something about it. They may need to find the right scars, the right chemical patches, the right disrupted terrain, the right place where the ice has failed to keep the deep world completely hidden. That is why the surface no longer feels like a barrier alone. It feels like a map, a dangerous map, because radiation has burned parts of it, a confusing map, because geology has folded and rewritten it, a partial map, because the ocean below may only leave traces in certain places, but still a map. And Webb has shown that at least one of those places carries a chemical signature we cannot ignore. Europa, then, is not terrifying because it looks violent. It is terrifying because it looks quiet while being forced open from within. If Europa is a map, then Jupiter is the hand constantly smearing the ink. No story about Europa can stay focused only on the ice, because the ice is trapped inside one of the harshest neighborhoods in the solar system. Jupiter is not merely a planet beside it. Jupiter is an environment. Its magnetic field is enormous, powerful, and filled with charged particles that sweep around the planet with devastating force. Europa moves through that environment again and again, and its surface pays the price. This is where the hopeful picture of an ocean world becomes darker. On Earth, the surface is where life announces itself. Oceans touch the air. Plants change the color of continents. Microbes alter atmospheres. Biological activity can become visible from far away if a planet's surface and air carry the right chemical imbalance. But Europa's most interesting environment is not on the surface. The surface is the punished layer. It is the place where radiation strikes first, where fragile molecules are damaged, where any exposed trace of deeper chemistry begins to change the moment it reaches the outside. That makes Europa's surface both a clue and a trap. A molecule detected there may have started somewhere else. It may have been born in the ocean, altered in the ice, exposed in chaotic terrain, then transformed again by radiation. Or it may have been made at the surface through radiation chemistry from ingredients that were already present. Or it may have come from outside entirely. The surface can tell the truth, but rarely in its original language. Jupiter keeps translating it. This is why Webb's ability to map chemistry region by region matters so much. If radiation affected every part of Europa in the same way, interpretation might be simpler. But Europa is not uniform. The radiation environment varies with location. The surface terrains vary in age and texture. The composition changes from place to place. The ice may be cleaner in some regions and more contaminated in others. The younger a region is, the less time radiation may have had to erase or transform its original chemistry. So the question becomes more delicate. Where on Europa is the surface still fresh enough to remember what happened underneath? Where has radiation already rewritten the evidence beyond recognition? Where are we seeing chemistry from the ocean, chemistry from the ice shell, chemistry made by charged particles, or chemistry imported from outside? Europa does not present one mystery. It presents a layered crime scene, with every layer partly contaminated by the next. Terra Regio becomes powerful in that context because it is not just chemically interesting. It may be geologically important. If its terrain is relatively young or altered, it could preserve clues that older regions have lost. The carbon dioxide signal there does not automatically mean ocean material has reached the surface, but it means that this is exactly the kind of place where future missions will need to look with extraordinary care. Care is the key word. The search for life beyond Earth often suffers from impatience. People want a yes or no. They want a signal, a body, a fossil, a cell, a clean announcement that the loneliness of Earth has ended. But Europa resists that kind of storytelling. It forces a slower, more disciplined kind of wonder. Before life, there is habitability. Before habitability, there is chemistry. Before chemistry can be trusted, there is context. Before context, there is the brutal problem of what Jupiter has done to the surface. And Jupiter has done a lot. The same radiation that makes the surface hostile might also help create oxidants, chemically reactive substances that could, in theory, become useful if transported downward into the ocean. This is one of Europa's strangest possibilities. The surface may not only receive clues from below, it may also manufacture materials from above that could eventually feed chemistry below, if the ice shell allows exchange in both directions. That turns the ice shell into something more than a barrier. It becomes a potential conveyor, a slow and complicated mediator between the skyless ocean and the radioactive space environment. From below, salts and carbon compounds may move upward. From above, radiation-altered oxidants may be produced and perhaps carried downward. Between them lies the ice, not dead, not simple, but acting like a thick, damaged, moving interface. If that exchange is real, Europa becomes one of the most fascinating chemical engines in the solar system. But again, the word "if" has to remain visible. We do not yet know how efficiently surface materials are transported downward. We do not know whether oxidants reach the ocean in meaningful amounts. We do not know whether ocean-derived material reaches the surface often, rarely, or only in certain terrains. We do not know whether the ice shell is thin enough in places for exchange to happen quickly, or thick enough to make it painfully slow. The system may be active, but the rate of that activity may decide everything. A world can have the right ingredients and still fail if the timing is wrong. That is a hard truth in astrobiology. The universe may be full of almost habitable places, worlds where water exists but chemistry is poor, worlds where chemistry exists but energy is missing, worlds where energy exists but materials never mix, worlds where everything necessary appears somewhere but never meets in the right place for long enough. Europa could be one of the great successes, or one of the great almosts. Webb cannot decide that, but Webb gives the question more texture. It shows that the surface carries chemical differences worth mapping. It makes certain regions more suspicious. It gives future missions a sharper set of targets. It adds another piece to a story that will not be solved by one telescope, one flyby, or one headline. The real exploration of Europa will be cumulative. A spectrum from Webb, magnetic measurements from spacecraft, ice-penetrating radar, gravity data, high-resolution imaging, thermal maps, surface composition studies. Each instrument will not reveal the ocean in full. Instead, each will press against a different part of the locked door. One will ask how thick the ice is. One will ask where the surface is young. One will ask what materials are present. One will ask whether the interior conducts electricity like a salty ocean should. One will ask where future sampling might have the best chance of touching material that once belonged deeper down. And that is why Europa's silence feels so loaded. It is not the silence of emptiness. It is the silence of a world whose most important evidence may be present only in fragments, only in certain places, only for a limited time before radiation changes it again. Webb has not made Europa easier to understand. It has made the difficulty more precise. The moon is not just hiding an ocean under ice. It is hiding the meaning of the ocean inside chemistry that Jupiter keeps rewriting. The closer Europa gets to feeling habitable, the more alien it becomes. That sounds like a contradiction, but it may be the most important emotional truth about this moon. The public often hears the word habitable and imagines a world becoming more Earth-like, warmer, softer, more familiar. A place where nature might have found a second version of the same story we know. But Europa does not become familiar when you make it more scientifically interesting. It becomes stranger. The possibility of life does not make the moon gentle. It makes every hostile feature more important. The radiation is not just danger. It is chemistry. The ice is not just a barrier. It is a possible transport system. The darkness is not just emptiness. It is the normal condition of any ocean sealed away from the sun. The cracks are not just scars. They may be the only surface language the hidden interior can speak. This is where the search for life begins to leave behind the childish version of itself. We are not looking for another Earth wearing a different sky. We are looking for processes. We are asking whether matter can organize itself in places where sunlight never reaches, whether chemical energy can replace daylight, whether an ocean can remain active under ice, whether carbon-bearing compounds can survive enough violence to tell us something true about the world below. Europa forces the question to grow up. If life exists there, it would not be life in a garden. It would not be life under blue air. It would not know sunrise, seasons, clouds, or weather in the way we understand them. It would belong to pressure, salinity, darkness, rock, and chemistry. It might be microbial, sparse, slow, and hidden in environments that would feel less like an ocean paradise and more like the inside of a machine. And that is only if life exists at all. The stronger, more responsible story is that Europa may be testing the boundary between chemistry and biology. It may show us how many ingredients a world can gather before life appears, or how many it can gather without life ever beginning. It may be alive. It may be sterile. It may contain chemistry that looks suggestive but never crosses the threshold. Any of those outcomes would be profound, because each one would tell us something about how rare or common life might be in the universe. This is why Webb's detection matters beyond Europa itself. The telescope did not simply add a fact to a fact list. It helped refine a method. It showed that even for worlds we cannot land on yet, even for oceans we cannot sample, we can start to identify places where interior chemistry may be exposed, altered, or concentrated. We can use light to choose targets. We can use spectra to decide which scars deserve closer attention. We can build a path from remote observation to future exploration. That path is slow, but it is real. A future spacecraft can approach Europa with questions Webb helped sharpen. Which regions contain carbon-bearing materials? Which terrains are freshest? Which parts of the surface show signs of recent modification? Where might the ice preserve evidence before radiation damages it too deeply? Where would a lander have the best chance of sampling material that has not spent too long exposed to Jupiter's charged particles? Those questions sound practical, almost engineering-like, but beneath them is something much larger. Where should humanity touch a hidden ocean world for the first time? That is the thought that changes Europa from an object into a threshold, because one day, if the sequence of exploration continues, we may stop treating Europa only as something to observe from afar. We may send machines close enough to skim over its surface in detail, to measure its gravity and magnetic response, to peer into its ice with radar, to map heat, to taste particles if any are thrown into space, and perhaps eventually, to land. A lander on Europa would not be arriving on a welcoming shore. It would be arriving in a radiation storm, on brittle ice, under Jupiter's enormous presence, with limited time to gather evidence before the environment begins to destroy the machine. It would be less like landing on a beach, and more like placing a fingertip on the lid of a vault, while the vault is being blasted by invisible fire. And still, that fingertip might be enough. If the right material is exposed at the surface, a lander would not need to drill all the way to the ocean to change science forever. It could analyze salts, carbon compounds, radiation products, textures, grains, and isotopic patterns. It could search not for a dramatic creature, but for chemical relationships. It could ask whether the surface materials look like they were processed in an ocean. It could test whether the carbon-bearing compounds Webb saw are part of a broader system. This is how the first real answer may arrive, not as a single shocking image, but as a chain of measurements that slowly eliminates simpler explanations. That is harder for headlines, but better for truth. The universe rarely gives its deepest answers in the form we want. It gives gradients, ratios, spectra, patterns, anomalies, and uncertainties. It gives us a surface that looks white and asks us to notice the invisible absorption lines. It gives us a moon that looks dead and asks us to understand tidal heating. It gives us an ocean we cannot see and asks us to infer it from magnetism, geology, and chemistry. It gives us carbon dioxide in a broken terrain and asks us not to overclaim, but not to look away either. Europa rewards patience and punishes fantasy. That is why the phrase, "Webb found something beneath the ice," has to be understood carefully. Webb did not see beneath the ice in a literal sense. It did not image the ocean. It did not watch material rise through a crack. What it found was surface chemistry that may be linked to an internal source, in a place where that link matters. The beneath is not a photograph. It is an implication, a tension in the data, a possibility made sharper by where the chemistry appears. And sometimes implication is enough to change the way a world feels. Before Webb, Europa was already one of the great ocean worlds. After Webb, Tara Regio feels more like a specific doorway in the ice, even if the doorway is still locked, even if we cannot yet tell what has passed through it, even if the signal has been blurred by radiation and time. The moon becomes less like a sealed mystery and more like a mystery with coordinates. That is a different kind of fear. Not fear that something will leap out. Fear that the answer may be close enough to pursue, and still difficult enough to evade us for decades. Fear that the first signs of another living system, if they exist, may be damaged, partial, and almost indistinguishable from non-living chemistry, unless we learn exactly how to read them. Fear that life beyond Earth may not announce itself. It may only stain the ice faintly and wait for us to become careful enough to notice. Europa does not ask us to believe. It asks us to become precise. By the time the story reaches Europa's surface, the question has already changed. At first it seems like a search for something hidden under ice, a buried ocean, a locked world, a place where the answer must be deep, dark, and unreachable. But Webb's observation pulls the mystery upward. It suggests that the most important clues may not be waiting only at the bottom of the ice shell. Some may already be on top of it, exposed in fragments, altered by radiation, scattered across terrain that looks broken, because the moon itself has never been completely still. That is where Europa becomes almost unbearable as a target. It is not far enough away to dismiss. It is not close enough to understand. It sits in the middle distance of human possibility, tempting us with evidence that can be measured, while keeping the decisive evidence beyond the reach of every instrument we have placed there so far. This is the psychological trap of the moon. It gives us enough to continue, never enough to finish. A world with no clues would be easy to leave alone. A world with obvious life would end the question. Europa gives neither. It gives magnetism that hints at a salty ocean. It gives a young, fractured surface. It gives chemical patches. It gives chaotic terrain. It gives carbon dioxide in a region that may be geologically meaningful. It gives enough coherence to feel designed by nature as a test of patience. But the test is not only scientific, it is philosophical. Human beings have spent centuries imagining life beyond Earth as a question of distance. We thought the Great Barrier was space itself, the emptiness between worlds, the years of travel, the faintness of distant stars. Europa reveals another kind of barrier, life. If it exists beyond Earth, may not be hidden because it is impossibly far away. It may be hidden because it is sealed inside places we can reach but cannot easily enter. That is more unsettling. A planet around another star can remain safely abstract. Europa cannot. It is local. It is part of our own solar system. We have photographed it. We have mapped it. We have sent spacecraft through the Jovian system. We can calculate trajectories to get there. And still, the most important environment on Europa may be protected by kilometers of ice and surrounded by radiation strong enough to turn the surface into a hostile laboratory. It is near enough to accuse us of not knowing. This is why Webb's data changes the mood of the whole moon. The telescope is not a drill, but it makes the surface feel less final. It tells us that the ice carries chemical differences, and some of those differences gather in places where the surface itself seems disrupted. That means Europa's surface is not merely the thing blocking us, it is also the thing speaking, however faintly. For the ocean below, The problem is learning its language. A crack is not just a crack if it marks stress. A patch is not just a patch if its chemistry differs from the planes around it. A chaotic region is not just broken ice if it has exposed material that may have come from deeper layers. A spectrum is not just a graph if it points to compounds whose location changes the story of a world. Europa forces us to read indirectly. That may be how much of astrobiology has to work. We may not get living organisms placed neatly under a microscope. We may get environments, disequilibria, gradients, compounds, structures, and patterns that must be interpreted with discipline. The first evidence for life beyond Earth may not look alive. It may look like chemistry that refuses the simplest explanation. It may look like a surface feature in the right place with the wrong mixture of materials. It may look like a signal that only becomes meaningful after every non-living pathway has been tested against it. That is why restraint matters. The temptation is to make Europa simpler than it is, to turn carbon dioxide into life, to turn a hidden ocean into certainty of biology, to turn Webb's observation into a revelation it was never meant to be. But false certainty makes the moon smaller. It steals the real suspense. The truth is stronger because it is harder. Webb found chemistry that may be linked to an internal source, in a place where the surface looks geologically disturbed, on a moon that likely hides an ocean and endures one of the most destructive radiation environments near any major planetary body. That sentence does not need exaggeration. It is already extraordinary, because if Europa's surface is chemically connected to its interior, then future exploration has a strategy. We do not simply wander across ice. We target the scars. We study the disrupted regions. We compare terrain ages, radiation exposure, spectral fingerprints, and geological context. We ask where the ocean's chemistry, if it ever reaches the surface, would be least erased and most recognizable. Every mission becomes an act of narrowing. The search area shrinks from the whole moon to certain terrains. The question shrinks from, is Europa alive, to, what chemistry exists here, and how did it arrive? Then it shrinks again to, can any of this material be traced to the ocean? Then to, does that ocean have the ingredients and energy flow that life would require? And only after all of that can the hardest question be asked with any honesty. This is not less exciting than a dramatic claim. It is more exciting, because it is how reality is actually approached. Europa is not a stage for our imagination. It is a physical world with rules. If it has life, that life must fit the chemistry, energy, temperature, pressure, and timescales of the moon. If it does not have life, that absence must also fit those conditions. There is no shortcut. The answer, whatever it is, has to be earned through the materials. And Webb has added one more material clue. Carbon dioxide sounds ordinary because we know it from Earth. It is in our air, our breath, our climate, our oceans, our rocks. But on Europa, its importance comes from context. A familiar molecule becomes strange when it appears on an airless, icy moon, concentrated in a region where the ice has been disrupted, under conditions where radiation and interior exchange are both part of the story. The familiar becomes alien because of where it is found. That may be Europa's deepest trick. It takes things we think we understand, water, ice, carbon, ocean, surface, and places them in a world where none of those words behave comfortably. Water is hidden. Ice moves. Carbon may be a clue from below. The surface is a radiation-altered archive. The ocean, if it is connected, is not a blue promise but a dark chemical system sealed inside a gravitational machine. So when Webb scanned Europa, the horrifying part was not what it saw. It was what its data made impossible to ignore. Europa is not just a frozen moon waiting in Jupiter's shadow. It may be a world where the boundary between surface and ocean is damaged, active, and chemically meaningful. A world where the ice is not silence, but translation. A world where the first hint of what lies beneath may already be lying on top, half erased by radiation. waiting for us to learn how to read it. The most dangerous mistake is to treat Europa as if it were waiting to be solved by one discovery. That is not how worlds work. A world is not a riddle with a single hidden word. It is a system, and systems reveal themselves through relationships. The carbon dioxide matters because of where it is found. The location matters because of the terrain. The terrain matters because of the ice shell. The ice shell matters because of the ocean. The ocean matters because of rock, heat, salts, pressure, and time. And all of it matters because Jupiter keeps forcing energy into a moon that otherwise should have become a frozen relic. Europa is not one clue. It is a chain. Break one link, and the story changes. If the carbon dioxide is only surface radiation chemistry, then Tara Regio still matters, but the connection to the ocean becomes weaker. If the carbon dioxide is ocean-derived, then the surface becomes a more direct archive of the hidden interior. If the chaotic terrain formed through shallow ice processes, the story is one kind of geology. If it formed through deeper exchange, the story becomes more provocative. If radiation has transformed the original material beyond recognition, the evidence becomes harder to use. If some regions are young enough to preserve fresher chemistry, they become scientific treasure. Every answer creates a new branch. That is why future missions will not simply ask whether Europa has life. They will have to reconstruct the moon's logic. They will ask how thick the ice is, how often the surface is renewed, whether shallow pockets of brine exist within the shell, whether the ocean touches rock, whether oxidants from the surface can move downward, whether salts and carbon compounds from below can move upward, whether the chemical energy available is enough to matter, whether the surface we see is a faithful witness or a corrupted archive. The search becomes less like opening a box and more like learning a language whose grammar is geology. Webb gave us a word in that language. Not the whole sentence, not the answer, a word. But the word appeared in a place where the sentence may be written differently from the rest of the moon. Tara Regio is not just a name to remember. It is a reminder that Europa's clues are local. The moon cannot be understood by averaging it into a single icy surface. Some places may be old and radiation burned. Some may be younger. Some may be chemically altered. Some may be closer to whatever the interior has tried to say. This is why maps matter so deeply in planetary science. A map is not only geography, it is a way of preserving context. On Europa, the same molecule can carry different meanings depending on whether it lies in a fresh, disrupted region, an ancient plain, a radiation-heavy zone, or a fracture system. Remove the map, and the chemistry becomes almost mute. Keep the map, and the chemistry begins to speak. Webb's data helps turn Europa from a symbol into a place. That may sound small, but it is a major shift. A symbol can remain vague forever. Icy moon, hidden ocean, possible life. A place has coordinates. A place has regions. A place has histories written into different terrains. A place can be visited, compared, sampled, misunderstood, and revisited. The more specific Europa becomes, the less it belongs to fantasy, and the more it belongs to investigation. And investigation is slower than imagination. It has to be, because Europa is full of traps. Carbon is not life. Water is not life. Energy is not life. Even all three together are not automatically life. They are the beginning of a question, not the end of one. The universe may contain countless worlds where the ingredients gather but never cross into biology. It may contain oceans that are chemically rich but sterile, energetic but unstable, long-lived but missing some crucial pathway. Europa may be a second cradle, or it may be a lesson in how difficult cradles are. Either answer would change us. If Europa's ocean is alive, then life is not a one-world accident. It can begin in darkness, under ice, around a giant planet, far from the warmth of a star. That would mean biology is more inventive than our surface instincts ever allowed. It would mean the universe does not need Earth-like scenery to produce living chemistry. But if Europa is not alive, the results would not be empty. A lifeless Europa with water, carbon, and energy would be one of the most important failures ever discovered. It would show us that habitability has hidden conditions. It would teach us that ingredients are not enough, that oceans can be promising and still silent, that life may require not just materials but timing, cycling, concentration, stability, and perhaps a very specific kind of planetary luck. That is why the moon's uncertainty is so valuable. It does not merely ask whether we are alone. It asks what alone means. Are we alone because the ingredients are rare? Or because the transition from chemistry to biology is rare? Are ocean worlds common, but living ocean worlds rare? Are hidden biospheres scattered through icy moons? Or are we projecting Earth's success onto places that never had Earth's pathways? Europa compresses all of those questions into one bright, scarred moon. And Webb, by finding carbon dioxide concentrated in a disrupted region, has not answered them. It has made the compression tighter. It has given scientists a sharper reason to ask how the surface and interior communicate. It has turned the abstract phrase ocean world into a more physical problem. How does material move through the ice, and what happens to it when it reaches the radiation-blasted surface? That movement may be the key. Without exchange, Europa's ocean remains hidden behind a wall. With exchange, the moon becomes a dynamic system. The surface can feed oxidants downward. The ocean can send salts and carbon-bearing materials upward. The ice shell can become a mediator rather than a lid. Chemistry can cycle. Energy can move. Clues can appear where future missions might reach them. But exchange also makes interpretation harder. A cleanly sealed ocean would be inaccessible but conceptually simple. A connected Europa is richer and messier. Every surface compound could have a mixed history. Every sample could be a blend of ocean chemistry, ice shell processing, radiation alteration, and external contamination. A future lander might scoop material that carries the ocean's signature, but only after that signature has been distorted by every environment it crossed. The prize would be real, but never pure. That may be the deeper lesson Europa is already teaching us. The search for life beyond Earth will not always be clean. It may involve damaged evidence, indirect clues, ambiguous chemistry, and places where the most important material has been altered before we can touch it. We may have to become comfortable with uncertainty not as a failure, but as the terrain through which truth is reached. Europa is not making the search easier. It is making the search more honest. The closer the investigation gets to Europa, the less useful the word discovery becomes. Discovery sounds clean. It suggests a moment when confusion breaks and the truth stands there, simple and complete. A telescope looks, a signal appears, a mystery ends. But Europa is not built for that kind of ending. It is built to complicate every answer until the answer becomes a map of processes. Webb did not discover Europa's ocean. That evidence was already built from decades of spacecraft observations, magnetic measurements, surface geology, and planetary physics. Webb did not discover life. It did not even discover a direct sample of the ocean. What it added was a sharper chemical clue on the surface, in a region where geology already looked suspicious. It gave the hidden ocean story another point of contact with measurable reality. That may not sound dramatic until you understand how little contact we actually have. Most of Europa's important world is invisible. The surface is the only part we can observe directly. Yet the surface is also the part most distorted by space. The ocean may be the main event, but we cannot see it. The rocky sea floor may be where chemical energy is produced, but we cannot touch it. The ice shell may control where the surface and ocean exchange materials, but even its thickness and behavior are still questions. Europa is a world where the most important places are separated from us not by empty distance, but by layers. That changes the feeling of exploration. We are not looking across the universe at something forever unreachable. We are looking at a nearby moon that keeps its evidence physically covered. It is not hidden by light years. It is hidden by ice. And ice is more frustrating than distance because ice invites effort. It feels like something that can be crossed, drilled, melted, penetrated. But on Europa, that simple fantasy becomes a nightmare of engineering and biology. Any mission that tried to reach the ocean would have to survive radiation, land safely on uncertain terrain, avoid contaminating one of the most important astrobiological environments in the solar system, melt or drill through unknown kilometers of ice, communicate through that ice, and operate in darkness under crushing conditions. The ocean is not just hidden, it is protected by difficulty. That is why surface chemistry matters so much. If the ocean's materials can reach the surface, even in altered form, then the moon may offer a shortcut. Not an easy shortcut, but a scientifically possible one. We might learn about the ocean without entering it. We might sample a disrupted region, analyze the compounds, compare them to models, and decide whether the surface bears the fingerprint of something deeper. But that possibility comes with its own danger. A shortcut can mislead. If surface material has been altered too much by radiation, it may no longer tell us clearly where it came from. If ocean-derived chemistry is mixed with compounds created in place, the signal may become ambiguous. If carbon dioxide forms through multiple pathways, then finding it in Terra Regio becomes a powerful clue, but not a verdict. The closer we get, the more we must resist the desire to simplify. That is the discipline Europa demands. Not less wonder, more careful wonder. The moon does not become less beautiful when we refuse to overclaim it. It becomes more beautiful because the real situation is richer than the fantasy. A sealed ocean world under Jupiter's radiation. A surface divided into terrains with different histories. Chaotic regions that may preserve traces of disruption. Carbon-bearing chemistry in places that matter. Ice that may be layered, modified, and physically complex. A telescope reading molecular fingerprints from a world hundreds of millions of kilometers away. No exaggeration improves that. The danger of false hype is that it makes the actual universe seem smaller than it is. If we say Webb found aliens, we erase the real achievement. We erase the precision of spectroscopy, the difficulty of interpreting an irradiated surface, the decades of work that made Europa meaningful, and the slow construction of knowledge from partial evidence. We turn a profound mystery into a disposable claim. Europa deserves better. It deserves the unease of the truth. The truth is that a moon can look dead and still be geologically and chemically provocative. The truth is that a surface can be both a barrier and a message. The truth is that life, if it exists elsewhere, may not be waiting in an Earth-like scene, but in an ocean with no sky, beneath ice, powered by chemistry, hidden so well that its first trace might be a molecule altered almost beyond recognition. And the truth is that we may find nothing alive there. That possibility should not be treated as failure. It should be allowed to keep its weight. If Europa has no life, then the question becomes almost as important as if it does. Why not? What was missing? Was the ocean too chemically harsh? Was energy insufficient? Was exchange between surface and ocean too weak? Did the ingredients never concentrate properly? Did time fail to arrange them? Did life require a pathway that Europa never had? A lifeless Europa would still teach us what habitability is not. That matters because astrobiology has to become more than optimism. It has to learn how worlds fail. It has to learn the difference between promising and living, between water-bearing and biologically active, between chemical richness and actual metabolism. Europa may become one of the first places where those distinctions are tested with real data instead of speculation. Webb's observation is part of that test. It narrows the uncertainty. It does not erase it. It helps identify surface chemistry that future missions may revisit. It ties the abstract idea of internal material to a specific region. It gives scientists another reason to treat Europa's surface as an archive, not just an obstacle. It strengthens the case that the next stage of exploration should be targeted, contextual, and patient. The word patient matters because Europa may not reward speed. The Moon has taken billions of years to become what it is. Its evidence may be faint, damaged, and unevenly distributed. Its most meaningful materials may appear only in certain terrains, at certain depths, after certain resurfacing events, before radiation has had too much time to erase their history. To understand Europa, we may need to read it the way we read ancient manuscripts, not by grabbing one fragment and declaring the story finished, but by comparing handwriting, layers, damage, missing sections, and repeated patterns. The surface is a manuscript written in ice and radiation. Webb has illuminated one phrase, and now the harder work begins, deciding whether that phrase belongs to the ocean beneath. If Europa's surface is a manuscript, then every future mission has to become a reader with better eyes. Webb has shown that the Moon can be read from far away, but not completely. A telescope can detect spectral fingerprints and identify regions where chemistry differs from the surrounding ice. It can help reveal that Tara Regio is not just visually strange, but chemically important. Yet Webb cannot tell the entire history of a molecule. It cannot watch the path carbon took before it reached the surface. It cannot say whether the carbon dioxide was born in the ocean, altered in the ice, formed by radiation, or produced through a sequence where each stage left only part of the truth behind. That is why the next layer of Europa's story belongs to spacecraft. A spacecraft can fly close enough to turn a suspicious region into a landscape. It can measure details that a distant telescope cannot resolve. It can compare one fracture with another, one patch of ice with another, one chaotic terrain with another. It can ask whether the places that look young also look chemically fresh. It can map where radiation has done the most damage. It can look for heat where the surface should be cold, for roughness where the ice should be smooth, for patterns that reveal how the shell has moved through time. The difference between a telescope and a spacecraft is the difference between seeing a stain on a locked door and kneeling close enough to examine the grain of the wood. Europa needs both. From far away, Webb gives context. Up close, future missions can give structure. They can ask whether the carbon dioxide is part of a larger chemical family. They can examine whether Tara Regio contains salts, altered ice, or materials that suggest exchange with the interior. They can study whether other chaotic regions show similar signatures or whether Tara is unusual. That comparison matters, because one strange region may be an exception, but a pattern across multiple terrains could reveal a process. Science loves patterns because patterns survive doubt better than isolated facts. One detection can be debated. Many detections arranged across geography become harder to dismiss. If carbon-bearing compounds cluster in disrupted terrains, that points one way. If they follow radiation patterns, that points another. If they appear where surface renewal is likely, the story changes again. Europa's answer may not be hidden in the strongest signal alone, but in the relationship between signals. This is why maps, spectra, geology, and physics have to be fused. A chemical map without geology can mislead. A geological map without chemistry is incomplete. A radiation model without surface composition misses the material being transformed. An ice shell model without real terrain risks becoming too clean. Europa is too messy for any single instrument to own the truth. It has to be approached as a world where every clue modifies every other clue. That is also why the search will take time. Even the best mission will not arrive and instantly reveal everything. It will gather passes, build coverage, test models, revise assumptions, and turn unknowns into smaller, more precise unknowns. That may sound disappointing only if we expect exploration to behave like entertainment. In reality, This is the drama. The moon becomes more real as the uncertainties become sharper. A vague mystery is easy to sell. A precise mystery is harder to escape. Europa is becoming precise. The old version of the story was simple enough to fit in a sentence. An icy moon may have an ocean under its crust. The newer version is stranger and better. An icy moon likely has a global ocean, a radiation-processed surface, geologically disrupted terrains, carbon-bearing chemistry concentrated in at least one chaotic region, and possible pathways by which interior and surface materials may interact. That is not a slogan, it is a system. And systems are where life, if it exists, must actually live. Life is not found in the word ocean. It is found in gradients, cycles, membranes, reactions, nutrients, waste, stability, and change. An ocean alone does not make a biosphere. The ocean needs chemistry that can do work. It needs energy that can be harvested. It needs environments where complex molecules can persist long enough to matter. It needs exchange without destruction, stability without stagnation, movement without total chaos. Europa may have some of those conditions. It may not have all of them. That uncertainty is where the scientific tension lives. The moon is not a yes or no written in ice. It is a balance of competing requirements. Too little exchange, and the ocean becomes isolated. Too much radiation at the wrong stage, and fragile chemistry is destroyed. Too little energy, and reactions may stall. Too harsh an ocean, and complexity may never gain a foothold. Too little concentration, and ingredients remain too diluted to organize. Habitability is not a checklist where 3 boxes guarantee life. It is a dynamic condition, and Europa's dynamics are still only partly known. This is why the surface cannot be treated as a simple preview of the ocean. Even if material from below reaches the surface, it has passed through a filter. The ice shell filters it. Time filters it. Radiation filters it. Geology filters it. Any future sample gathered from the surface will not be a cup of ocean water. It will be a transformed remnant, a chemical survivor. Scientists will have to work backward from that survivor, asking what original environment could have produced it and what processes altered it along the way. That backward work may be painfully difficult, but it may also be the only realistic path for a long time. To send a machine through Europa's ice and into the ocean is one of the great dreams of planetary exploration. But dreams must answer engineering. How does the machine avoid contamination? How does it survive the surface? How does it melt downward without losing communication? How does it navigate unknown ice full of impurities, fractures, and possible brine pockets? How does it operate once it reaches water under pressure? How does it send back enough evidence to justify the risk? A surface mission is not easy, but it is closer to possibility. And if Webb is right that certain surface regions carry chemistry linked to the interior, then the surface becomes not a compromise, but a target with meaning. The mission would not simply land anywhere flat enough to survive. It would seek the places where the ice has a story to tell. The scars become coordinates. The chaos becomes a clue. The carbon becomes a reason to look harder. That is what makes Europa feel like a turning point. It asks humanity to move from wondering whether hidden oceans exist to learning how to investigate them responsibly. It asks us to stop treating icy moons as background objects and start treating them as possible worlds of chemistry, exchange, and deep time. It asks us to build instruments that can distinguish promise from proof. And it reminds us that the first step toward another ocean may not be diving into it. It may be learning to read the ice above it. The question now becomes what kind of answer Europa could actually give us. Not the answer we want. Not the one that makes the cleanest headline. The answer the moon itself is capable of giving. Through ice, chemistry, radiation, and time. That distinction matters because some worlds can be studied directly. A rover can grind into Martian rock. A lander can scoop soil. An orbiter can watch storms on a planet with an atmosphere. But Europa hides its most important environment beneath a barrier that may be thicker than many mountains are tall. Its ocean, if sampled directly one day, may require technologies that still belong more to future engineering than present capability. So Europa may answer first through damaged evidence. A patch of chemistry, a terrain boundary, a cluster of compounds, a relationship between a surface scar and a spectral signal, a pattern repeated across multiple regions. These are not weak clues simply because they are indirect. They are the kind of clues a sealed ocean world can offer before anyone reaches the ocean itself. The danger is expecting them to behave like proof too soon. If future missions find more carbon-bearing compounds in chaotic terrains, that would strengthen the case that these regions are important. If they find salts that match expectations for ocean-derived material, the story becomes more powerful. If they find patterns suggesting relatively recent surface renewal, the clues become fresher. If they find that certain compounds are too altered by radiation to interpret, the story becomes harder. If they find no meaningful connection between disrupted terrain and internal chemistry, then Webb's clue becomes one part of a more complicated surface process. Every possibility has to remain open until the evidence closes it. That is what makes Europa so scientifically beautiful and so emotionally difficult. It refuses to become a simple promise. It offers hope, then surrounds that hope with conditions. Water, yes, but buried. Chemistry, yes, but altered. Energy, perhaps, but uncertain in its delivery. Surface clues, yes, but damaged by Jupiter. A possible pathway, yes, but not yet proven. It is a moon made of yes, but, and that phrase may define much of the search for life beyond Earth. Yes, Mars had water, but its surface changed. Yes, Enceladus throws material into space, but its ocean must still be understood. Yes, Titan has organic chemistry, but its surface is unimaginably cold. Yes, Europa may have a deep ocean, but it hides that ocean under ice and radiation. The solar system is full of worlds that approach habitability from strange directions, each carrying part of the story and withholding the rest. Europa's version is especially intense because the missing piece is not whether water exists. The missing piece is whether the system works. Does the ocean meet rock in a way that produces useful chemistry? Does the ice allow exchange? Do surface oxidants reach the ocean? Do ocean materials reach the surface? Are carbon compounds distributed by geology, radiation, impacts, or some combination of all three? Is the ocean chemically balanced in a way that could support metabolism? Or is it only an impressive volume of dark water? This is the point where the word ocean becomes dangerous. Ocean sounds alive to us because Earth's ocean is alive. But Earth's ocean is not alive because it is water. It is alive because of everything water does inside a planetary system. Dissolving minerals, transporting chemistry, cycling nutrients, storing heat, interacting with rock, atmosphere, sunlight, and biology across immense time. Remove some of those connections, and water becomes less of a cradle and more of a container. Europa may be a cradle, it may be only a container. Webb cannot choose between those futures, but it can help us ask which surface places might remember the difference. That is why Tara Reggio keeps pulling the story back, not because it is guaranteed to be the place where Europa reveals itself, but because it shows what a meaningful target looks like. Not just an interesting molecule, not just strange geology, but the overlap of both. In planetary science, overlap is often where the truth begins. A chemical anomaly in ordinary terrain may be one kind of clue. Strange terrain with ordinary chemistry may be another. But strange terrain with unusual chemistry creates pressure. It forces models to account for both the surface form and the surface composition. It asks whether the same process can explain the broken ice and the carbon-bearing material, or whether multiple processes have collided there. That pressure is useful. It narrows the field of imagination. It makes scientists stop talking about Europa as a general wonder and start asking specific questions about specific places. That is how exploration matures. It moves from awe to coordinates, from possibility to target selection, from there may be an ocean to this region may preserve material that tells us something about that ocean. And yet, even that maturity does not remove the unease, because the closer we get to a target, the more consequences attach to touching it. Europa is not just another rock. If it has a habitable ocean, then any future landing or sampling mission carries responsibility. We would be approaching a world that might host an independent biology, or might preserve prebiotic chemistry, or might represent a rare natural laboratory for understanding how life does or does not begin. Contamination becomes more than a technical concern. It becomes an ethical boundary. To study Europa properly, we have to avoid bringing Earth too carelessly with us. A machine sent there must be clean enough not to confuse the search, and careful enough not to damage the very environment it was sent to understand. That is another reason the surface matters. Sampling surface material linked to the interior may offer a way to learn without immediately invading the ocean itself. The ice becomes not only a scientific archive, but a protective distance. This is what makes Europa feel like a threshold rather than a destination. A destination is a place you arrive. A threshold is a place where you decide how to enter. Webb has brought us closer to that threshold by making Europa's surface feel less mute. The telescope's data suggests that at least some parts of the ice carry chemical signals worth treating as more than decoration. It has turned the surface into a possible witness, and witnesses must be questioned carefully. But a witness can be confused. Radiation can distort testimony. Geology can mix old and new material. Impacts can import foreign chemistry. Ice can bury and expose evidence on timescales that are difficult to reconstruct. Even a true clue can become misleading if separated from the process that made it. So the next era of Europa exploration will be about context. Not just detecting molecules, but understanding their journey. Not just mapping cracks, but asking how they formed. Not just identifying carbon, but tracing whether that carbon fits with an internal source. Not just celebrating an ocean, but testing whether that ocean participates in a living chemical system. The horrifying part is not that Europa is dangerous. The horrifying part is that it may be meaningful. A dead, frozen moon would be simple. A living ocean world would be revolutionary. Europa stands in the narrow, trembling space between those possibilities. Bright enough to observe, close enough to visit, sealed enough to resist us, and chemically strange enough that we cannot honestly look away. It does not give us the comfort of certainty. It gives us the responsibility of attention. The more carefully we read Europa, the more the word life begins to lose its easy shape. On Earth, life has had billions of years to teach us what to expect. It climbs towards sunlight. It changes air. It stains rocks. It builds forests, reefs, soils, shells, bones, and cities. Even when it hides inside a planet already saturated with biology. Earth makes life feel obvious because Earth has been rewritten by it. Europa, if it has life at all, would not announce itself that way. There may be no atmosphere for biology to alter, no green surface, no ocean exposed to light, no seasonal bloom visible from orbit, no fossils lying dry under a rover's wheels. If life exists there, it may be locked in darkness, separated from the surface by ice and from our instruments by one of the most difficult barriers in planetary exploration. Its first detectable influence might not be a shape, it might be chemistry, a pattern, a disequilibrium, a set of molecules in a place where non-living processes struggle to explain them all at once. That is a humbler kind of search. It requires letting go of the image and trusting the relationship. Not a creature, but a context. Not a face in the ice, but a system that seems to be doing chemical work. This is why Europa matters so much. It pushes astrobiology away from fantasy and toward the hardest version of the question. How would we recognize life if it never looked like life? Webb's observation does not answer that, but it helps set the stage. The carbon dioxide in Tara Regio is not a biosignature. It should not be treated as one. It is not evidence of organisms. It is a clue about chemistry and possible internal sourcing. Yet clues like this are part of the path that eventually allows a deeper question to be asked. Before anyone can search for biology responsibly, they must first understand the non-living system. They must know what Europa can make without life, what radiation can produce, what the ocean might contribute, what the ice can transport, and what geology can expose. Only then can anything unusual become meaningful. That may be the most overlooked truth in the search for life. You cannot recognize the extraordinary until you understand the ordinary. On Europa, the ordinary is already strange. Ordinary means ice under stress. Ordinary means radiation splitting molecules apart. Ordinary means a surface younger and more disrupted than a dead frozen shell should be. Ordinary may mean brines moving inside the ice, salts mixed into the crust, carbon compounds altered by charged particles, and surface materials with histories that begin far below where sunlight can reach. If that is the baseline, then life has to be distinguished from an already complex chemistry. That will not be easy. Imagine a future mission landing near a region like Tara Regio. Its instruments begin to analyze the surface. They find salts, carbon-bearing compounds, oxidized materials, perhaps molecules that suggest alteration by water. The world reacts instantly. Every headline leans toward the same question. Is it life? But the scientists would have to slow the moment down. They would have to ask whether each compound can form without life, whether radiation can explain it, whether ocean chemistry can explain it, whether contamination can be ruled out, whether the pattern is local, regional, or global, whether the molecules occur in relationships that point toward an active system rather than random mixing. The public would want a verdict. Europa would give a puzzle. That puzzle may be the most realistic first contact with a potentially habitable world. Not a signal, not a message, not a dramatic organism under a camera, a set of measurements that sit uncomfortably between geology, chemistry, and biology. Until enough context gathers around them. This is why Webb's role is so valuable. It does not bring the ending closer in a theatrical way. It brings the beginning into focus. It helps identify where future missions might search for that context. It shows that Europa's surface is not chemically featureless. It shows that certain regions deserve special attention. It reminds us that if the ocean ever communicates with the surface, the message may appear first as molecular geography. Molecular geography is not a phrase that sounds emotional, but on Europa, it is almost intimate. It means the moon is not just a white sphere. It has places that differ from other places. It has chemical neighborhoods. It has terrain that may carry a different memory than the plains around it. One region may be more recently disturbed. Another may have been exposed longer to radiation. Another may preserve a clearer trace of what rose from below. The whole moon becomes less like an object and more like a body with scars of different ages. And in those scars, the story may be hiding. The fear is not that Europa will attack us. It is not that Webb uncovered something monstrous. The fear is that the evidence may be almost enough, close enough to tempt us, ambiguous enough to divide us, real enough to demand another mission, damaged enough to prevent certainty. Europa may not deliver one clean revelation. It may pull humanity into a long relationship with uncertainty, where every answer makes the next question sharper. That is often how the universe teaches, not by satisfying curiosity all at once, but by making curiosity more disciplined. Before Europa, many people imagine the search for life as a search for a place. Find the right planet, find the right moon, find water, find the answer. Europa shows why that is too simple. The place is only the beginning. The real question is whether the place has the right exchanges, the right cycles, the right chemistry, the right stability, the right disturbances, and the right protection. Life is not a label attached to water. It is a process that must be sustained. And if Europa has that process, it may be hidden in the least cinematic place imaginable. Not on the surface, not in a beam of light, not under an alien sky, but somewhere beneath ice, around minerals, in darkness, where chemistry has had time to become something more. If it does not, the silence will still matter. A silent Europa would tell us that even a world with an ocean, energy, and carbon can remain unalive. That would make Earth feel less inevitable. It would make life seem more conditional, more fragile, perhaps more rare. It would remind us that the universe can assemble stages without ever beginning the play. Either way, Europa changes the question. We are no longer asking only whether there is another ocean beyond Earth. We are asking whether an ocean hidden from every sunrise can become a world. At some point, every search for life becomes a mirror. We look outward because we want to know whether Earth is alone. But the farther we follow that question, the more it turns back on us. Europa does not only ask whether life can exist under ice, it asks what we think life needs. It asks whether we have mistaken familiar scenery for universal law. It asks whether sunlight, air, and open water are the essence of habitability, or merely the version that happened to raise us. That is why Europa feels so disruptive. It does not offer a second Earth, it offers a second possibility. A world where the ocean has no sky. A world where the surface is not a home but a hazard. A world where chemistry may be driven by gravity, rock, water, and radiation instead of weather and sunlight. A world where the most important boundary is not between land and sea, but between ice and ocean, surface and depth, evidence and erasure. Webb's observation belongs to that larger transformation. A telescope looked at a scarred icy moon and found a chemical clue in a broken region. That single act forces the imagination to stop treating Europa as a smooth white symbol. It becomes a layered place, a difficult place, a world where a molecule on the surface may carry a history that began below, passed through ice, and survived long enough to be read as missing light. There is something almost unnerving about that. The clue did not come as a voice. It did not come as a biological shape. It did not come with certainty. It came as a concentration of carbon dioxide in Terra Regio, a region already strange because the ice there looks disrupted. It came in the quietest form possible, not an announcement, but a pattern. And patterns are how the universe often speaks before we understand the language. The first planets beyond the sun were not seen as beautiful worlds. They were inferred through motion and dimming. The earliest evidence for the expanding universe was not a photograph of space stretching, but a shift in light. The afterglow of the Big Bang was not a visible fire, but microwave radiation filling the sky. Again and again, the deepest truths arrive first as signals that seem too subtle for the size of what they imply. Europa may be entering that category, not because Webb has solved it, but because Webb has made it harder to look at the moon as a simple frozen object. The ice now feels less like a blank wall and more like a surface where hidden processes may have left partial signatures. The moon still withholds the ocean, but it may not withhold everything. Somewhere in its fractured shell, the boundary between inside and outside may be imperfect. That imperfection is the story. A perfect barrier would make Europa almost unreachable. A broken, moving, chemically active barrier makes it testable. It also makes it more confusing. The same cracks that might expose material may also mix it. The same radiation that might create useful oxidants may destroy fragile compounds. The same surface that may preserve clues may alter them beyond recognition. Europa's greatest hope is inseparable from its greatest difficulty. This is why the moon cannot be reduced to optimism. There is a kind of cheap hope that says, there is water, therefore there is life. Europa destroys that shortcut. Water is only the beginning. A world must also have usable energy, the right chemistry, environments where reactions can persist, and pathways that allow materials to cycle. Even then, life is not guaranteed. We do not yet know whether biology is an easy consequence of chemistry or a rare accident that required Earth to thread a narrow needle. Europa stands at that uncertainty, like a locked experiment. If it is alive, then life can emerge in darkness, under ice, far from the sun's warmth, in a world powered by forces very different from the surface of Earth. That would expand the possible habitats of the universe enormously. It would make icy moons, rogue planets with internal heat, and ocean worlds beyond the traditional habitable zone feel more important. It would mean the universe has more doors for life than our first instincts allowed. If it is sterile, that silence would also be enormous. It would tell us that water and carbon and energy are not enough. It would suggest that habitability has hidden thresholds we have not yet understood. It would make Earth feel stranger, not less. A living Earth beside a lifeless Europa would force us to ask what happened here that did not happen there. What sequence of chemistry, environment, stability, and chance turned one ocean world into a biosphere while another remained only an ocean? Both outcomes are too important for hype. That is why the honest story is the strongest one. Webb did not find life. Webb did not open the ice. Webb did not see the ocean. Webb found a chemical clue on the surface of a moon that may hide an ocean. And the clue appears in a place where the surface itself looks geologically disturbed. That is enough. It is enough because the real question is not whether we can make the discovery sound bigger. The real question is whether we can become careful enough to follow it. Care is not the opposite of wonder. Care is what wonder becomes when it grows up. A careless imagination turns Europa into whatever we want it to be. Alien ocean, hidden biosphere, terrifying secret. A careful imagination lets Europa remain itself. A bright, frozen, radiation-battered moon with a likely global ocean, a fractured ice shell, complex surface chemistry, and a handful of clues that may lead us toward one of the deepest questions humans can ask. That version is more beautiful because it is real, and it places responsibility on every future step. The next spacecraft must not only search, it must distinguish. It must separate surface chemistry from ocean chemistry, radiation products from internal material, wishful thinking from evidence. A future lander must not only touch Europa, it must understand where it touched, what that place has survived, and how much of the deep moon's story might still be present in the sample. The first true contact with Europa's ocean may not be a splash. It may be a careful measurement of ice, a grain, a compound, a ratio, a pattern that says this material did not begin where it was found. A line of evidence that points downward, not with certainty, but with enough force that the next mission becomes inevitable. That is how thresholds are crossed. Not all at once, not with a single dramatic reveal, but by turning faint clues into precise questions, and precise questions into machines capable of answering them. Europa is waiting in that slow future, but not passively. It is orbiting, flexing, cracking, freezing, being irradiated, perhaps exchanging material between ocean and surface, perhaps preserving in broken places the chemical memory of what lies below. From far away, it still looks white and silent, but after Webb, that silence feels different. It no longer feels empty. It feels like a moon holding its breath beneath the ice. And so the story returns to the image that started it all. A small white moon moving through Jupiter's domain. A frozen body, bright against darkness, scarred by lines that look almost delicate from far away. No oceans visible, no atmosphere wrapping it in weather, no surface that welcomes a human imagination, just ice, radiation, gravity, and a hidden interior that refuses to become simple. Before Webb, that image already mattered. After Webb, it feels less like a picture and more like a warning. Never mistake a quiet surface for a quiet world. Europa's silence is not the silence of emptiness. It is the silence of distance, ice, and incomplete evidence. It is the silence of a moon whose most important place cannot yet be seen directly. It is the silence of chemistry that may have travelled through a frozen shell only to be damaged by radiation before we could read it. It is the silence of a locked ocean, leaving possible fingerprints on the outside of its own prison. That is why the discovery feels unsettling, even without exaggeration. Webb did not find life. It did not open the ice. It did not prove that Europa's ocean is habitable, or that anything swims in the dark below. What it did was more precise. It showed carbon dioxide concentrated in a region of disrupted terrain, a place where the surface itself already looks like something happened. It gave scientists a chemical clue in a geological wound. That is enough to change how the moon feels, because the question is no longer only whether Europa has an ocean. The evidence for a subsurface ocean is already strong enough to make Europa one of the most important targets in the solar system. The deeper question is whether that ocean participates in the surface world, whether material from below can rise, whether radiation products from above can descend, whether the ice is a wall, a filter, a conveyor, or all three at once, whether the moon is merely preserving water or running a system. The system can be tested. A system can fail. A system can surprise us. This is the final tension Europa leaves behind. It may be one of the best places beyond Earth to search for the conditions of life, and yet it may also teach us how easily those conditions can fall short. It may contain an ocean with chemistry rich enough to matter, or an ocean that remains sterile despite everything we hoped. It may hold biology in darkness, or it may hold only the lesson that life requires more than water, more than carbon, more than energy, more than time. Either answer would be enormous. A living Europa would break one of the oldest human assumptions, that life belongs to worlds like ours, under sunlight, on surfaces, beneath skies. It would mean biology can begin in a sealed ocean around a giant planet, far outside the comfortable warmth of Earth. It would widen the map of possible life in the universe, making icy moons and hidden oceans feel less like exceptions and more like doors we had not learned to open. A lifeless Europa would be just as haunting. It would mean nature can build almost everything we think life needs and still stop short. It would mean an ocean can endure for ages and remain silent. It would make Earth feel stranger, more specific, perhaps more fragile. It would force us to ask what hidden condition turned our world from chemistry into biology, while another ocean world stayed unfinished. That is why Europa matters beyond Europa. It is not only a moon, it is a test of our assumptions, a test of whether habitability is common or rare, a test of whether life begins easily when given the right materials, or whether the leap from chemistry to biology is one of the hardest transitions in the universe. A test of whether our own planet is ordinary in the deepest sense, or only ordinary in the comforting way that every home feels ordinary from the inside. And Webb has made that test sharper, not by giving us certainty, but by giving us direction. Terra Regio is not just a strange name on a map. It is a place where the surface and the chemistry overlap in a way that demands attention. The carbon dioxide there may be internally sourced. It may be ocean-linked material altered by surface processes. It may be part of a more complex sequence involving geology, radiation, and time. But whatever the final explanation becomes, Webb has shown that Europa's ice is not a blank page. It is a damaged archive. A future mission may read it more closely. It may map the region with finer eyes, Measure the chemistry with greater precision. Compare Terra Regio with other chaotic terrains. Search for salts, organics, oxidants, heat, layering, and evidence of exchange. It may find that the clue points downward, or it may find that the surface has fooled us. But even being fooled would teach us how Europa works, and learning how Europa works is the only honest path toward asking whether it is alive. The moon does not owe us a dramatic ending. The universe rarely does. It offers partial truths, and asks whether we are patient enough to assemble them. It offers light with certain wavelengths missing. It offers ice broken into patterns. It offers a molecule in the wrong place, or the right place, depending on what the next mission finds. It offers a world that looks frozen, then quietly suggests that frozen does not mean still. That is the broken illusion at the heart of Europa. Ice does not always mean death. Silence does not always mean emptiness. Distance does not always mean impossibility. And a surface that looks like a barrier may also be the only available language of the ocean below. So the horrifying part was never that Webb saw something monstrous. The horrifying part is that Webb made Europa more real, more specific, more testable, more difficult to dismiss, more capable of changing the way we think about oceans, life, and the hidden architectures of worlds. Europa is no longer just a beautiful, icy moon beside Jupiter. It is a place where surface chemistry may be carrying the memory of an unseen interior, where the boundary between dead ice and living possibility remains unresolved. And now we know where to look harder. Somewhere on that bright, scarred surface, in a region of broken ice, a telescope found carbon dioxide written into the light. Not proof, not life, not an answer, a clue. And sometimes, in science, a clue is more powerful than a conclusion because it does not close the door. It tells you which door is worth approaching. Europa still turns around Jupiter, white and silent, carrying its ocean through darkness. The surface freezes, the radiation strikes, the ice cracks, the hidden sea remains unseen. But after Webb, that silence is no longer empty. It is the silence of a locked room whose walls may already be marked from the inside.